All right, I've got my virtual chalkboard ready, so let's dive into this explainer and prep the team for defeating the absolute ultimate hurdle on your career schedule, the notoriously difficult 6G welding test. Look, whether you're aiming for pipeline work, power generation, or high-end fabrication, passing this test is literally the gateway to the highest-paying jobs in the industry. But a staggering number of working welders fail this thing on their very first attempt. So we're going to decode exactly why that happens and sketch out the ultimate playbook to help you pass it. Here is our chalkboard game plan for today's session. The ultimate welding hurdle, cracking the codes, preparing for the test, avoiding common weld defects, executing the 6G weld, and surviving the bend test. Let's get right into it. Section 1. The ultimate welding hurdle. Scouting the opponent. So first up, we need to understand exactly why this test is considered the absolute pinnacle of welder qualification. The 6G position is a monster. Why? Because it forces you to fight gravity in a single continuous revolution around the pipe. The pipe is fixed at a 45-degree angle, and you absolutely cannot rotate it. Because of this, you are forced to seamlessly transition through the flat, vertical, horizontal, and overhead positions all on one single joint. That comfortable muscle memory you rely on for standard flat or vertical plate welding? Yeah, you can throw that right out the window here. But wait, it actually gets crazier. Sometimes contractors will call an audible out in the field, requiring what's known as the 6GR test. That R stands for restricted. They'll literally place a restricting ring half an inch above the weld joint, or even stuff the pipe into a simulated boiler tube box, completely limiting your visual access and your mobility. You might even be forced to use a mirror or weld half the joint left-handed and half right-handed. It's designed to simulate brutal, real-world field obstructions where you just can't stand comfortably. Section 2. Cracking the codes, understanding the rulebook. Before you even think about striking an arc, you have to know the rules of the game. And that brings up the million-dollar question, right? Does passing this incredibly hard test automatically mean you're certified for all the easier pipe positions? Well, the answer completely changes your certification strategy, and it depends entirely on who is writing the rules. Under ASME Section IX, if you pass the 6G, it's considered a comprehensive qualification. You're fully cleared for all pipe positions, 2G through 6G. Boom, done. But AWS D1.1, they adopt a totally different philosophy. Under AWS, the 6G test alone actually does not qualify you for all pipe positions. They make you run a two-part play, requiring you to pass the 5G horizontal fixed pipe test in addition to the 6G just to be fully qualified. Knowing this upfront prevents you from walking away thinking you're fully certified when, legally, you just aren't. Section 3. Preparing for the test. Locker room prep. You know, the biggest reason welders fail isn't actually on the field. It's inadequate preparation before the arc is ever struck. Skipping any of these critical setup steps is basically forfeiting the match. First, read the WPS, the welding procedure specification. If that WPS calls for stringer beads and you go in with a weave technique, you fail, period. Next, verify your fit-up. Veteran inspectors will tell you that if your root gap varies by even 1/32 of an inch, the amperage you need for proper penetration shifts and boom, you've introduced defects. And please, don't forget your equipment. A quick test of your voltage and gas flow prevents a faulty machine from ruining a perfectly good coupon. I absolutely love this piece of locker room wisdom sourced directly from the pros over on Reddit. It is so simple, but so crucial. Always, always grind off rust, paint, and mill scale until you are looking at shiny silver metal. Contaminants are the mortal enemy of a sound weld, leading straight to trapped gas and undercut. Taking an extra 5 minutes to prep your metal is going to save you hours of heartache later on. Section 4. Avoiding common weld defects. Avoiding the penalties. It is time to warn you about the major penalties that lead to immediate visual or NDT, non-destructive testing rejection. Out of a recent sample of 250 test takers from one testing facility, 3 technical errors were the absolute biggest killers. Number 3 was surface porosity. Number 2 was trapped slag. But the number 1 reason people fail the 6G test? It might actually surprise you. It's arc marks. The hidden metallurgical damage caused by a simple, careless arc strike outside the weld groove is severe. When you accidentally strike your arc on the parent material out there, you cause rapid, localized heating and high-rate quenching. This literally changes the steel's molecular structure, turning it into this untempered, super brittle martensitic microstructure. It makes the metal prone to snapping like glass. To a strict inspector, An arc mark isn't just a surface scratch. It is a major crack initiation site and an instant, non-negotiable failure. Now, you also need to know exactly how your technique triggers those other penalties. If you're suffering from lack of fusion or cold lap, it's very often because your travel speed is just too slow. The puddle rolls ahead of your arc, creating a thermal barrier. On the flip side, if you are getting porosity, those tiny, maddening trapped gas holes, it's highly likely your arc lengths or contact tip to work distance is just too long. When your arc distance gets too wide, it breaks the gas shield, allowing atmospheric nitrogen and oxygen to just rush in and completely ruin your weld. Section 5. Executing the 6G weld, running the plays. Okay, time to step onto the field. Let's sketch out the actual execution strategy with 4 essential steps. Step 1, always keep your electrode pointed toward the dead center of the pipe, whether you're on the root, the fill, or the cap pass. Step 2, keep that arc length incredibly tight for maximum puddle control. Step 3 is crucial. You must account for gravity. On the bottom of the pipe, gravity is pulling your puddle away. On the top, it's actually helping you fill. So you have to dynamically adjust your travel speed and angle as you revolve around the pipe. Do not just weld square to the joint. And step 4, weld the pipe in halves rather than quarters. This significantly reduces the number of starts and stops you have to make, which, as we know, are prime real estate for defects. But what if the testing code totally bans grinders? Actually, this happens pretty often to simulate thin wall pipe field conditions. Well, if grinders are outlawed, you must rely entirely on technique. Practice feathering your tack wood smoothly with a hand file so your root pass blends in cleanly. Keep your restarts hot because restarting on hot metal naturally produces a much smoother tie-in. And piggyback your restarts by overlapping your previous speed by at least 1/4 inch, pausing just briefly to burn in properly before you advance the puddle.
Section 6. Surviving the bend test. The final whistle.
Because, look, passing the visual and NDT inspection only gets you halfway there. You still have to survive destructive mechanical testing, specifically the guided bend test. This is where things get real. An inspector cuts a strip out of your beautifully welded coupon, places it on a jig, and a hydraulic plunger violently forces your specimen into a severe U-shape. This intentionally stresses the metal to its limit to check for ductility and to brutally rip open any hidden flaws or lack of fusion. Depending on the thickness of your pipe and the specific code you're testing under, inspectors will subject your coupon to different types of bends to stretch every single zone of your joint. A face bend puts the weld cap on the outside tension curve. A root bend puts the vulnerable inside root on the outside. And for really thick materials, they'll actually slice the weld sideways for side bends, testing the entire cross-section from the root all the way to the cap. 1/8 of an inch. Let that number sink in. After your metal has been bent completely into a U-shape, that convex surface is meticulously examined. And for most codes, 1/8 of an inch is the absolute maximum allowable size for any open crack or discontinuity. It is a razor-thin, incredibly tight tolerance for victory. If your crack is even a hair larger than that, you fail, and you have to start the entire grueling process all over again. Which brings us to the end of our chalkboard explainer today. We've scouted the 6G's brutal 45-degree angle, we've decoded the ASME and AWS rulebooks, prepped the fit-up, analyzed the defects, sketched out the continuous execution plays, and survived the hydraulic band test. Use this playbook and respect the process. But, it leaves us with one final, very real thought. Passing the 6G isn't just a test of your physical technique. It is a massive test of your psychological endurance under pressure. When you step into that booth and strike that final arc, will you let the gravity of the test control you, or will you control the weld?